Today we're going to start a very important part of Chapter 4, and this is in Section 7, which is the composition of functions. We're in the new notes packet on page 1, so this is the notes that you got handed out to you today, and if you were absent in class today, this is you can print this out from my website. So first of all, a composition operation, you see a little O in here. This is a composition. This is like, you can think of an operation like addition and subtraction, multiplication and division, but this is a different kind of operation called composition. And you have to have two functions. Well, you're using two functions, f and g. And when you do the composite, you see a little O in between them. It means that the function f follows the function g. What that means is the second function is applied to the result of the first. This is the second function. It is applied to the result of the first function g. So f follows g. It means g is first, f is second. G is done first, f is done second. And there's two different ways of writing composition. There's this little O that's between the two functions, or you can also nest the parentheses, and this is called the inner function, or this is the first function, this is the second function. And both are said f of g of x. So the word of is important, f of g of x. So you have two things going on. So what do I mean by this? Well, first we're given two functions. These are just randomly defined functions. I said f of x is x squared. G of x is x plus 1. They don't have anything to do with each other. They're just two functions that I defined. Now what we're going to do is evaluate. When you're asked to evaluate something, you give a numerical value. So if we evaluate f of g of 3, what we're going to do is we're going to do g of 3 first. So I'd like you to draw just a light box in there. You're going to cover up the f function, so we're going to do g of 3 first. Well, what's g of 3? G of 3 is just 3 plus 1. So g of 3, 3 plus 1, that's equal to 4. So what we're going to do now is we're going to take the result of this, and we're going to do f of 4, because whatever we got in this first function is applied to this function. So f of 4, well, we just replace the 4 in for this x, which is 4 squared, which is 16. So that first result is 16. That's our answer. So we'll just go through another example of this. In this example, f is the first function and g is the second function. So what we have to do is let's cover up g first. First of all, we're going to figure out what f of 2 is first. Well, what is f of, or negative 2? What is f of negative 2? Well, you go over to this f function and put in negative 2 for the x. So it's negative 2 squared, which is positive 4. And then what you're going to do is you're going to drop this g function down here. We're going to do g of 4 now, right? Because that was the result of the first function. Or if you want to put it over here, you can, g of 4. So g of 4 is equal to 4 plus 1, which is just equal to 5. So there's your answer to the second problem. So remember, just do the right function first, the left function second, based on this result. Okay. These next two problems, they're asking you to find the rules. Well, rules are different than evaluating. When you find a rule, your answer is going to have an x in it. So let's just put a note. Answer will probably have an x in it instead of just a number like 16 or 5. Okay, so what we're going to do now is we're going to find the rule of f of g of x. Well, how do you do that? Well, same thing as before, you're going to cover up the f function, and you're just going to write down what is g of x. We don't have a number to put in, but it's just the letter g of x. Well, what is g of x anyways? Well, g of x is x plus 1. So let's just write down what g of x is, x plus 1. All right, that's that. Now what we're going to do is we're going to drop down the f function, and what we're really doing is f of g plus 1, or f of x plus 1. So what is f of x? Well, f of x is x squared, so no matter what goes in here, we're going to square it. So f of x plus 1 is x plus 1 squared. And how do you square x plus 1? Well, you have to FOIL x plus 1 with itself. And if you've done this enough times, I hope you have by now, you'll see that it's x squared plus 2x plus 1. So there would be the rule. This is the rule. It's not an evaluate because we don't have a number, but it's a rule. Over on the other side, we've got the opposite. We've got g of f of x. So now we're just going to cover up the little g function here. And what is f of x anyways? Well, f of x is x squared, just like it always has been so far today. And what we're going to drop this g function down, so we're going to do g of x squared. Well, if g of x is x plus 1, then g of x squared is x squared plus 1. So there's the answer to this one. You can't really do anything else to it. So there's the answer. So you can see that f of g of x has a rule, g of f of x has its rule, and notice they're not equal to each other. Might want to put this down. Not equal. So in other words, composition is not commutative, right? Like if you do f plus g, it would be the same thing as g plus f, but not composition. They're not commutative. All right, let's go through this next example. It's pretty much like the other example above, but I've just given you two new f and g's. So we've got a different f and a different g. So let's just practice this. What do we do first? We cover up the f, and we're going to figure out what is g of 5. Well, g of x is x minus 3, so g of 5 is 5 minus 3, which is equal to 2. And now we're going to drop that f function down, and we're going to do f of 2. Drop that f function down. So f of 2 is 2 squared plus 2, if that's f of x. Well, 2 squared is 4, and 4 plus 2 is 6, so this answer is 6. And over here we're going to do g of f of negative 4. So how do you do that? Cover up the g function. You're going to figure out f of negative 4. Well, f of x is x squared plus x. So f of negative 4 is negative 4 squared plus negative 4. Negative 4 squared is 16. 16 minus 4 is equal to 12. So now we're going to drop the g function down, and we're going to do g of 12. G of 12 is 12 minus 3, which is 9. So that's our answer here. And now again, we're going to find the rules. Remember, evaluate will give you a number answer like a 6 or a 9. But when you have to find a rule, your answer is probably going to have an x in it like it did up here. Here's a rule. So what are we going to do with this rule? We're going to cover up the f function and write down what g of x is. Well, g of x is x minus 3. So we're going to write down x minus 3 here in place of the g of x. Drop the f function down. And what is f of x minus 3? Well, here's f of x, x squared plus x. So we're going to take x minus 3 and square it, plus x minus 3. So every time you see an x, you're just going to replace it with an x minus 3. Well, we've got a little work to do here to simplify this. This is x minus 3 times itself, plus x minus 3. And this is a FOIL. So after you get done foiling this, x times x is x squared, minus 3 is minus 6x, and negative 3 times negative 3 is positive 9. And then you have plus x minus 3. And now one more step and we're done. We can combine these like terms. Negative 6 and positive 1 is negative 5, and the 9 minus 3 is equal, whoops, I forgot my x here, and 9 minus 3 is 6. So x squared minus 5x plus 6 would be the rule for that. Over here, let's do it the other way. F of x, we're going to write down as x squared plus x, and we're going to do g of that function. Well, g of x is x minus 3. Anytime you see an x, you take it out and you put x squared plus x in its place. So we've got x squared plus x, that's gone now, minus 3. And that's all you can do for that one. So here again, you can see that f of g of x is a different answer than g of f of x. They're not commutative. They're not the same. So down here, I've got that summarized. Note, since f of g of x is not equal to g of f of x, and we saw that up here, it's not a commutative operation. Now let's take a look at the next page. The next page is composition of functions, but now we're going to do it graphically. Before we were doing it algebraically, but this is a graphical definition now. Graphical means we're going to have a graph to look at. So when you're finding f of g of x graphically, then what we're going to do is find the value of the right function first, and then we're going to find the value of the left function. Let me raise this up so you can see it. All right, so what do I mean by that? Well, what we have here is we have an f function. You can see it's really tiny. It says f of x, so let's just put a bigger, just so you can see it better. This one is f of x, and this one you can kind of see, but we'll just call this g of x. So we have two functions, just like before, but this time it's a picture instead of an equation. So what we're going to do here is we're going to find f of g of 3 from these two graphs. So how you do this is you're going to cover up the f function. You're going to figure out what g of 3 is. Well, g of 3 means go over to the g graph, which is this one. When x equals 3, what does y equal? We'll go over to 3, y equals 1. So g of 3 is equal to 1. So what we're going to do is find f of 1, because this g of 3 is equal to 1 from the other graph. And now what we're going to do is we're going to go up to the f graph, because we're doing f of 1, and it says when x equals 1, what does y equal? So up to this graph, f of 1, going all the way up here, this y value is 5. So the answer here is 5. In the second example, we're first going to find f of negative 2. F of negative 2 says, when x is negative 2, what is y? Well, you're going way down here, and when x is negative 2, y is negative 4. So we're going to do g of negative 4, because that's what f of negative 2 is. Go over to the g graph, and when x is negative 4, what is y? Well, y is positive 4. So the answer here is 4. All right, I'm going to skip this one. I'd like you to do this one on your own. I'm going to skip this one. Well, actually, let me show you how to do this because it's written a little bit differently. What you do is you find the inner function first. So you're going to do g of negative 4 first. So g of negative 4, oh, we've already done that today. That's equal to positive 4. So we're actually doing f of positive 4 because g of negative 4 is equal to 4. And then f of 4, go over to 4 on the x-axis. And where does it hit? What is the y value? The y is negative 4. So the answer here is negative 4. All right, so now I'm going to have you do number 4 on your own, g of f of 1. And you can actually have the same function be the inner and the outer. It doesn't really matter. What you're going to do is do g of 6 first, because that's the inner function. So g of 6 is equal to 4. So you're going to drop this function. G of 6 gets replaced with 4. And what is g of 4? G of 4 is right there. G of 4 is equal to 2. So 2 is your answer to question number 5. All right, these two graphs are giving you new definitions of f and g. So this is f, this one is g, and now let's use these new graphs to evaluate these. So f of g of 2, you're going to find out what g of 2 is. G of 2 is equal to 3. So let's do f of 3. Over here, what is f of 3? F of 3 is equal to 5. So there's your answer there. Let's see. I'll have you do this one on your own. Find f of negative 2 and then g of that value. You do this one on your own. Find g of negative 8 and do f of that value. And I'll have you do this one on your own. And then I'll do this last one, number 10, with you. So f of 3. F of 3 is, we've already done it, 5. So we're actually doing f of 5 because that's what that evaluated to. So what is f of 5? We're going to go all the way over to 5 here. Go up to this point. It looks like 6 would be the answer to this one. F of 3 is 6. All right, so tomorrow in class, I'm going to check your page 2. When I do your homework check, I'm going to make sure that your number 4 is done and your numbers 7 through 9 are done. And then I'll go through a couple of these with you, and then I want you to finish them up on your own. This is the same. I'm just giving you two new definitions of f and g. So here's f, here's g. F of g of 4. Well, first we do g of 4. G of 4 looks like it's equal to 5. And now we're going to do f of 5. F of 5 looks like it's equal to 3. So number 11's answer is 3. Number 12 is done the same way. First we do f of negative 2. F of negative 2 looks like it's 2. So we're going to do g of 2. What's g of 2? G of 2 looks like it's 6. So 6 would be the answer here. Did I get this right? Let's see, g of 4. You know what? G of 4 is not 5. G of 4 is 3. I made a mistake here. So can you fix my issue there? Because I just read that wrong. And now we're going to do f of 3. Well, f of 3 on this graph is actually equal to 5. So this answer is not 3. It's equal to 5. Oops, almost made a mistake there. All right, so that's it for this video, but please finish up all of the ones that we didn't do so I can give you a nice mark on your homework check tomorrow. Bye.